I'm Cole Jenkins. This is Sweet Density Lab for the class that's 9 to 9:50, Monday, Wednesday, Friday, Physical Science. So today we're going to be calculating the density of two candy bars, one Snickers bar, one Milky Way, and we're going to be calculating the density for the whole candy bar on each, and then we're going to cut them in half, and we're going to see if the density changes once we've cut them in half. So to get the density, you need to know the mass and the volume, because density equals mass over volume, and volume is length times width times height. So let's start with the Milky Way bar, and let's get the mass of the Milky Way bar. So Milky Way is going to be 52.2 grams, and the Snickers is going to be 52.7 grams. So now we're going to measure the length, width, and height of the Milky Way. So let's see. The length of the Milky Way is about 9.44. So we'll just say 9.4, we'll round it off. The width is going to be 2.9. The height is going to be about 1.6. So all those multiplied together get 43.62. 43.62. So density equals mass over volume, and the mass is 52.2. So once we plug in 52.2 divided by 43.62, we're going to have 1.20. And we convert it to grams by milliliters. So it's going to be 1.20 grams per milliliters. So that is the density of the Milky Way. Now the Snickers, we have to get the length, width, and height. So the Snickers length is, it's about 9.6. The width is about 3 centimeters. And the height is 1.9 centimeters. So we're going to multiply those together just like we did with the Milky Way. 3 times 1.9. We're going to get 54.7. Well, 54.72 to be exact. But so if you remember, the mass of the Snickers bar was 52.7. So we're going to divide those. 52.7, 54.72. And we convert it to the same thing as we did for the Milky Way. So we get 0.96 grams per milliliters as the density. Alright, so now when we calculate the density for the bars once they've been cut in half, the only things that are going to change is obviously the length. It's going to be half of the original. And so that'll change the volume. So the length once cut in half of the Milky Way would be 4.7. So let me get a new piece of paper real quick. So the length of the Milky Way is 4.7. So we'll We can measure these out, but you really can just divide by 2 of what you initially got on the length. But the width and height will remain the same. So it'll be 4.7 times 2.9 times 1.6, and that'll give us 21.808. That's centimeters cubed, because it is the volume. And you just take the original weight in grams and put that half, once we've cut it in half, divided by 2. And the measurement is 26.1, so we're going to take 26.1, divide that by 21.808, and we're going to get the same density, which is 1.20 grams per milliliters, which is the same as the first. So we shouldn't have to do the same thing, because I'm assuming it's going to be the same for the Snickers, but we can just do it anyway. So length of Snickers is 4.8, width is 3 centimeters, height is 1.9. So we just divide those by 2. So the volume, once you multiply those together, is going to be 27.36. And we take the mass and put that half on there, divide by 2, and we're going to get 26.35. So we take 26.35 divided by 27.36, and we're going to come out to the same density as 0.96 grams per milliliters. So that's that. Turns out the density was the same, so my hypothesis was correct. So that's it.